Hello and welcome to the Walking Talking topic on constructions and loci. Question number 3 with me, Mr. Barton. Now a two-part question here that's going to test your construction skills to the limit. McReardon Construction is contracted to work on a warehouse where there are a number of liquid storage tanks. A sketch of the base of one of the liquid storage tank is shown below. 3 meters, 3 meters, 3 meters. There's a nice equilateral triangle. Using a pair of compasses and a ruler, make an accurate scale drawing. And the scale 2 centimeters represents 1 meter. Right, let's get our length sorted first. So 2 centimeters is 1 meter. Well, we've got 3 meters, so I reckon that's going to be 6 centimeters. So we're going to need to draw a 6 centimeter, 6 centimeter, and 6 centimeter triangle. So if you draw a triangle, the first thing you need is a base, and it doesn't matter if this base is parallel or a horizontal line or anything, but people tend to draw it as a horizontal line, so I'm going to do that. So 6 centimeters there, and that 6 centimeters is going to represent my 3 meters, and I'll probably label that as 6 centimeters brackets 3 meters, just to show the examiner I know what I'm doing. And now to draw a triangle, I'm going to need my compass, and I'm going to need to set this at exactly 6 centimeters as well. So spiky end at 0 and be as accurate as you can, because they will check, and pencil at 6. Put them together, and I think there we go, that'll do. And then it is going to be spiky end at the end there of one of these, and draw yourself a lovely arc and be as light as you can with the compass. And then spiky end at the other end and turn it round if, like me, you're a bit dodgy with your left hand or whatever. Do it like that, do an arc. Now those arcs, if you've done it right, should cross in one place and one place only. And if you join them up with a straight line, you should end up with a triangle that looks a little bit like this, but do not trust that it's right. You might as well do yourself a little check. So if I label that 6 centimeters, 6 centimeters, and let's check it actually is 6 centimeters, because if it isn't, I'm going to be in a bit of trouble. Well, that's looking good for 6, and that one, that's looking pretty good for 6 as well. So there's my scale drawing. But the fun is only just getting going here, because we have a part B. What's happening here? McReardon Construction has been asked to lay a drain surrounding a different liquid storage tank. The drain must be exactly 2 meters away from the perimeter and the base of the tank. Here's a scale drawing. A scale of 1 centimeter to represent 1 meter has been used. Draw accurately the position of the drain surrounding the tank. Okay, so it's got to be exactly 2 meters away, and we've got 1 centimeter equals 1 meter, so I reckon that's got to be 2 centimeters away from each of the sides. Now this is pretty similar to question 1 that we did on this walking talking, in the sense that we've got the fairly easy bit of a horizontal line and a vertical parallel lines that are 2 centimeters away. We've got a slightly awkward bit that we've got a diagonal line there, but I think we'll be okay with that one. And then we're going to have to sort our corners out. So let's get these bits sorted first. So we need 2 centimeters away. Use my tip again from the previous video. Use your little bit of your ruler there just to line it up against the line to check that you're parallel. And let's put a dot there. I always do a safety dot in the middle just to check, and then a dot at the end. You always increase your chance of getting it right if you go for the 3 dot strategy. So that should be 2 centimeters away there. Let's go for this bit now. I'm going to measure 2 centimeters there, and notice this time I can use my entire ruler running along the side there to check that I'm parallel. 2 centimeters there, and let's go to the top, 2 centimeters there. Got 3 dots in, just check they line up. Yeah, that's looking good, always good for a little checking mechanism. Now this one's a little bit harder, but it's still going to be alright. And look what I'm going to do with my ruler this time. I'm going to go for just along here at the top there, and I'm going to go for 2 centimeters, place a dot. Notice what I'm doing. I've turned my ruler around, and what I'm doing is I'm lining up the line of my measurements so that it naturally follows right up the same gradient as the side of this triangle. And what I'm going to do, just to double my chances, is I'm going to put a few markers in here on this one. Let's go for one there. And it's almost, I mean it's not technically this, but it's almost like a line of best fit along my dots there. And I draw the line that goes through most of them. So that's looking pretty good. That's my kind of basics. And now I'm going to do exactly what I did before. I'm going to get my compass, and I'm going to set it to 2 meters, or sorry, 2 centimeters. And I'm going to hope that if I've done this accurately, it should join up beautifully and create like a running track like I did before. Now, my compass is a little bit dodgy at short distances, but hopefully this will work. It's looking fairly good so far. Join it up. There you go. Nice bit at the top. Get the spiky bit of the compass out here. Spin that round. I'll tell you what, I don't want to curse myself here, but this is the best I've ever done a compass. I'm putting it all down to the compass, because this is not wobbling at all here. I might have jinxed myself though. There we go there. And you get a beautiful, again, running track style. And if you were to pick any point here, and this is always the best way, every point is going to be exactly 2 centimeters from the line. Perfect. Right, one more question to go.